So, are you able to hear me, all of you?
Yes, I'm able to hear you.
How about you? Hello? So let's see, what is data mean. Data means something like, we can say, information. Okay? Data means information. And what is database mean? So what does database mean? Database means collection of related information, some information that need to be related. So what are the examples of database? We can say files, file storage. Files are the example, and Excel files or text files, all the files. So those are the examples of database. And also like whatever the paper writings we do, those are all databases. Okay. So some information, some collection of information. It can be anything. It can be a list of fruits, or it can be a list of students, or it can be as simple as some text, those things. So then what happened is, like, when we want some management of this data. So what happened is, when these grew like in a bigger size, then it became harder to maintain this database in papers and in folders and those kind of stuff. So there came some softwares. So softwares to manage the database. So they designed softwares, and Oracle is the first, they are the one who came up with designing the DBMS system to create the database. The organization is really first organization is called Relational Software. Some organization, they started creating the databases following the code rules and those things, like the production database, we need to say, like where you can use for the making the application development database. So those things. So then we have DBMS. So DBMS stands for Database Management System. So that is the database management system. And what does it mean? It is a software to manage database. Okay. So what does software to manage database means? We can do insert. We can insert data, update data, delete data, and query data, and maintain data. So these are the things we're gonna do on the database. So simply that. So can we design a database management system by our own? Yes, we can design. We can design like using simple Java or any other high-level language we can use, and we can design a database altogether by ourselves. We can also design. There was the period like where they designed a simple database management systems in the languages, but what happened is those are very tightly coupled to the data set they have, and they can't be used for other purposes. So there is much more like highly coupled, like very tight coupled things, and we can't separate them. So then there came like we also got the relational databases first. So relational database concepts, you can say. So what are those? We got normalization, normal forms. So we got normal forms. So what are these normal forms, like first normal form, second normal form, third normal form, fourth normal form? We got all those normal forms, and the concepts designed by Cod and other guys. So there was a time like where they came up designing the tables and keeping the relations between them and maintaining the data in the form of tables. So that's the relational concept of databases, and then afterwards, in order to maintain the data integrity, means the data related to one to another. I mean to say, like let us think, we have a course table and we have a student table. There shouldn't be something like a student registering for a course which is not existing. You got it? So we have a course table, we have a student table, and we have a registration table. So in the registration table, if you are recording like who all registered, which student registered for which course, then we shouldn't create a student registering for a course which is not existing in the course table. So that is something like we are losing the integrity. So everything should be integrity. So that's what the integrity stands for. And there shouldn't be any anomalies, data anomalies, like we update data some places, we don't update data some places, and those things. And there shouldn't be redundancies, something like like storing the same data multiple places many times in many tables. Something like we store the data like a student contact information inside the student table, and inside the course table we store them, and some wherever in the other tables we store those kind of things. So relational databases came to establish integrity. So integrity means you understood. So they should be tightly, like one should relate to other, like, and have high integrity. So high integrity, less data redundancy. So less data redundancy, and so these are the things, and anomalies, or we can solve. So these are the major concepts for data. So there came RDBMS softwares. So RDBMS softwares later. So like softwares to design the databases using these normal forms and maintain them. So what are the RDBMS softwares that are available in market? Oracle, Microsoft, SQL Server, and DB2. This is by IBM. Then we have MS Access. So Microsoft got two types of databases, and MySQL. So these are the databases that are mostly like we can think like there are many other databases also available, but these are some of the famous databases that are available in right now in the market, and these are all RDBMS softwares. So these using these softwares we can develop the databases, maintain them, and we can do all these stuff like insert, update, delete, query, and maintain. So that's some history behind like what how they came, and those things. And also at last we need to discuss something called SQL. So IBM came with this language. They made some syntax called SQL, structured query language. So so they came with this language, and using this language like a structured query language, they are able to maintain the data. So they did this one, and later it grew exponentially, and it became the basis for using the RDBMS softwares, and everybody started using SQL, and it's a must for any technical guy to learn the SQL. So one should know the SQL. Like if one need to be a technical guy, some kind of like though you take BA, QA, and anyone, BA, QA, and like developers, all the people need to at least know SQL. So it became a must, and it's a very simple thing to learn structured query. So I think you have understood. We just discussed what is data, and what is a database, simple definition of database, and what is RDBMS software, that is DBMS software, and we discussed about relational database. Then we discussed about RDBMS software that are available in the market, and structured query. So structured query language, so this is used to we can use this query language to actually query and maintain and create the database. So before going into structured query language, I just want to discuss few things. So database, so we will be having servers. So first we will be having DB servers. Inside the DB servers there will be databases. So there can be many databases in a server, and there can be many DB servers, and on the top of DB servers there can be environments. So that depends. So I'm just giving a, and under that there will be tables, views, stored procedures. So etc. So there will be tables, views, and stored procedures, and queues and triggers, indexes, etc. So indexes, triggers, etc. So those will be under databases. Take tables. Table will contain columns. And records. Okay, columns and records. So that is about tables. So table is something like the table you see, any table you see in the HTML, it looks like the same. So they contain columns, and we can say columns are columns are fields or other things, like we can also say, and records we can call them as rows. So that's about a simple understanding of data DB server. Okay, so let us take these and keep them in the relational databases. Okay. And coming to the structured query language, we can divide the structured query language into DL, DML. Then afterwards, you can say TCL, like transaction query language, and DCL, DML, DDL, DCL, DCL. That's it. So all those things. So DML. So DDL. So these are something like we are just dividing the keywords or the operations that we use in the SQL into different categories. There is nothing else, nothing like there is separate language like DDL language, DML language, TCL language, DCL language. This is simply a categorization of the commands. So we are just categorizing the commands, but this is nothing, something like we are not discussing something entirely different language. So all come under SQL language. So what does DDL stands for? DDL stands for Data Definition Language. So what does it do? So DDL does is to create and drop objects, database objects. Let us database objects. What are those database objects? Means, so these work on the database objects. What are the database objects? Like it can be a database, it can be a table, it can be a user, it can be yeah. So under server there will be databases and logins too. And here you will be having users also. So anything like all objects, like you can create database, you can create table, you can create a view, stored procedure, user, index, trigger, whatever you want to create, or we can create them and we can drop them. And DDL stands for Data Definition Language. So this deals about structure, mostly structure of data. See how the table structure of the database, what goes into the database. So this is about the structure of data. And DML stands for Data Manipulation Language. So what does this do? So data manipulation language means, so data manipulation language is for to maintain data. So to insert, update, delete data. That means this deals on directly on data. So directly on the data you are working on. And then transaction control language. So what does transaction control language do is to control transactions, we can simply say. So that's what it sounds. So to control transactions. What does transaction mean? Like you want to execute some bunch of SQL statements, and you want to execute them all together. If you want to execute them, you want to execute them together. If not, none. So all or none. Something like you want to do all or none. You want to do everything or you don't want to do anything. So that's about TCL. And what we have is data control language. So what does data control language do? So data control language is to give access to the data. So this is about to give access, grant and manage access to the data. So this is something like deals with security. So you wanna create users, you wanna create logins, you wanna create roles, and you wanna create permissions, and you wanna assign some roles to them. So this is about data control language. So broadly, like we can classify the SQL into SQL commands into these things. So let us see what does the keywords go into DDL. So DDL, the major keywords that go into create. You want to create a database, you want to create a table. Then you will say alter, you want to alter a table. Then you will say drop a table. And we also have one more called truncate. Truncate is other command. So these are the commands that go into DDL section. And we also have something like here DML, we have insert, update, delete, and yeah. So insert, update, delete, and you can also have select. So that's about DML statements. So these are the commands, like you can insert the data into table, update the data in the table, delete the data that is there in the table, and you can also select the data that is there in the table. So after that, for transaction control language, what are the commands that go into transaction? So something like begin transaction, so begin transaction, commit transaction, rollback. So begin means you're starting a transaction, commit means you're done with the transaction and you want to store the results. If you got an error and you want to roll back, then you can use the command rollback. So after begin, either it should go to commit or rollback, something like that. So that's about transaction control language. Then afterwards, what we have is data control language. So here we have the commands like grant, revoke. So what does this say is granting means you want to grant access to somebody. You want to revoke access to somebody. So you can do using these two commands. So this is some broad classification of SQL into different categories and what type of commands go into them. There are many other keywords that are available in SQL, but these are the like the top level things like one need to remember. So if somebody asks you, yeah, truncate is a DDL command or a DML command, you should say it's a DDL command. Why it is a DDL command? Why we placed it into a DDL? Why not into a DML? And all those things we are discussing. So that's about SQL structured query language. So just SQL DDL, DML, DCL, TCL. I'm just opening that one and going into the images. You can see here begin transaction, commit transaction, and rollback. Grant, revoke, create, alter, drop, select, insert, update, delete. So that's one. And here also we have truncate. He has not included, but some there will be. And there are many other things also. It's not limited to them. You can have truncate. You can see truncate here. And yeah, there is something like a describe, rename, and all those things. Something dealing with the structure goes here. So they call it as DRL, data retrieving language, I think, retrieval language. It depends, but though you classify them, you don't classify them, it's okay. It's okay you classify them or you don't classify them. So that's what. So we also have save point. So till now, any doubts? So what we discussed today is, again, I'm just wrapping it up. So we discussed what is a database, what is data, what is a database, and what is DBMS mean. DBMS means software to manage database. That can be any software. And then we discussed the relational database concepts, how they came, and then afterwards we discussed the concept of DB server and tables and classifying them, and then we discussed what are the RDBMS softwares that are available in the current market, and we discussed how the SQL made into shape, and what are the commands that go inside the SQL, those things. So this is about structured query language. I'm just saving this file, so save as. So drive classes, so API testing, I'm saving it as SQL. So yeah, I saved it as SQL. SQL means SQL, not SQL. It's a SQL class. Okay, so that's about the SQL. Okay, SQL introduction you can think of. So let's create some tables and do some operations now. So in order to do this, you need to install SQL Server into your system. So you need to install SQL Server into your system. So you can get a SQL Server Community Edition, or you can say SQL Server Express Edition. So it's a free, so you should say Express Edition. So SQL Server Express Edition is a free, like for a small level of applications, like it can hold 10 GB of size and entry-level database. So that's about SQL Server. You can download it, install it, see how to install SQL Server Express Edition in a video, follow the instructions, install it. Yeah, like you're gonna love it. It's very like rich UI and those things. So I'm just typing SSMS, SQL Server Management Studio. So this is a management studio. This is a client actually which can connect to the server, that is SQL Server. So using this client, you can connect to the server that is in the somewhere hosted on some different IP also. So you can connect to a different server at some place, and you can connect it to the same like server installed in your system or in a network or anything. So SQL Server Management Studio is a client. It's a database client, and nothing more than that. See, I'm connecting to some database that is hosted on some URL. I gave that, and I can also connect it. Just click connect, it will connect it. Or else, what I can do is I just go to my desktop, and here I can connect it directly. So there are two types of authentications. One is Windows authentication and the SQL Server authentication. SQL Server authentication is means like you need to provide login and password to log in, whereas Windows authentication checks are you a user in the current system. So this checks whether you are you a user in the current system and you are allowed to access the server. That's it. So this is about Windows authentication and SQL Server authentication. So I'm just clicking on connect. So you can see I'm able to connect to the server. So if you want to disconnect, I can come here, say disconnect, and you want to connect it again, you can say connect it again. And that's about how to connect to a server using the SQL Server Management Studio client. So after you connect, you can see here there will be databases, security, server objects, replications, polybase management. So don't worry about all these things. Our worry, like we should worry about the databases right now. So this is where we gonna create the database. So under the databases, you can see there are different databases that are available here. These are all the databases. So this is the icon of the databases. So inside the database there will be tables. You can see in the DB school there are tables like classes, registration, school, students, and this is where the table resides. And here there are views, and for stored procedures you can go into the programmability, stored procedures, functions, triggers, all these like types and all those things. So that's about programmability, and simply saying database has tables, okay, and views. So if you go into any one table, like I'm opening that classes table, there will be columns. So for every table there will be columns, and there will be primary key, something kind of that stuff here. So that is what that tables gonna contain. So that's about like our database and those things. And what else? So how to create the database and how to create the table and how to store things into them. Like we can discuss them right now. Like so to create a database. So how to do create a database, and you should give the name. So for example, I want to create a database called API database. So that's what I want to create, or API DB. API DB. So you want to create something like that. You can create something like this, and when you click execute, it's gonna create a database here. Or else you can also create a database saying that to create a new database and give the name over there, and it will give you a pop-up, and you can set the default sizes, how much size you want to have the database initially, and by how much you want it to increment and those things. So it's nice, like if you plan for a bigger DB, then you need to do the bigger sizes here. You need to do the estimation, and you just need to give here the something like API DB, and just click on here. There shouldn't be any space in between, and you just need to click on the OK, and it will create the database for you. But you can also create using this query window. So how to open this query window is, see, I'm just doing X mark, closing that one. After I opened it, so it's asking me whether I need to save it or not. Okay, so how to open that window is like you can say new query, and it opens a new window, and you can give your query whatever it is. And here, as we are creating the database, you can point it to the master database. Master database is the database that is given by the server itself, and it is the one which is responsible for storing the details of the server. So what are the databases that are inside the server, what are the tables that are inside the server, who are the users that are inside the server, what are those roles, and everything, like all those things get stored in the master database. So you can create them in the master database itself. So I'm just going and clicking on the execute. See, so when I click the execute, it will create a database here. You can come here and say refresh. it's created a database called API DB. But inside this DB there are no tables. You can see there are no views, there are no tables, and anything else. So you want to create the table, how to create a table, and how to insert data into a table, and how to delete data into a table, and all those things. Let's gonna see it tomorrow. Okay. So that's it for today. So today is the introduction to SQL databases, and do you have any doubts now?